Hello everyone, welcome to join me to get to know overhead power distribution lines. Overhead power distribution lines have the advantages of simple erection, low cost and convenient branching, making it easy to detect and eliminate faults. The disadvantages are susceptibility to external environmental influences, poor reliability of power supply, and affecting environmental cleanliness and aesthetics. Everyone, please look at this segment of overhead power distribution lines. Do you recognize these components? Overhead power distribution lines are mainly composed of insulators, conductors, cross-arms, fittings, poles, stays, and foundations. In this lesson, we will learn about the names, functions, and types of components of overhead power distribution lines. First, let's learn about poles. The function of poles is to support conductors, ground wires, insulators, fittings, etc., to maintain a sufficient safety distance between conductors and the ground, trees, buildings, and various crossing objects. Poles can be divided into cement poles, steel pipes, and iron tower based on materials. Cement poles, also known as reinforced concrete poles, have the advantages of durability, easy maintenance, and low operating cost. Compared with iron tower and steel pipe poles, they have slightly lower strength and poor stability. Construction and transportation are more challenging, especially in mountainous areas. In China, cement poles produced and used currently are classified into equal diameter poles and tapered poles based on their shapes, and into ordinary and pre-stressed types based on manufacturing processes. In recent years, steel pipe poles have gained popularity due to rapid urban development, large footprint of traditional iron towers, and incongruity with modern urban environments. However, the use of high-voltage cable is costly, and concrete poles have unsolved longitudinal and circumferential cracking issues, which steel pipe poles have addressed. Steel pipe poles use tapered steel pipe with circular or polygonal cross-sections, offering simple structure, easy manufacturing, convenient construction, safe and reliable operation, and low maintenance requirement. Iron towers have the advantages of long service life and high mechanical strength. However, in power distribution lines, they are less commonly used, as we won't delve into them here. Poles can be categorized by their purposes into several types. Straight poles set up along straight sections of power distribution lines, also known as intermediate poles. In flat areas, these poles make up about 80% of the total number, and under normal working conditions, they can withstand lateral wind loads on the line and the weight of conductors, but not unbalanced pulling forces in the line direction. Tension poles, placed between several straight poles, are stronger than straight poles. They use tension clamps and tension insulator, string, or butterfly insulator to secure conductors to the poles, and the conductors on both sides of the pole are connected by jumper wires. These poles can withstand lateral wind loads on the line and the weight of conductors, as well as unbalanced pulling forces in the line direction, and braking forces in case of accidents. Using tension poles allows the line to be divided into several tension sections, with the length of a 10 kV line tension section generally not exceeding 2 km. Corner poles are mainly used at line corners, and they come in straight and tension types. In addition to bearing vertical loads such as conductor weight and wind pressure, they also withstand the resultant force of the conductors at corners, which depends on the corner size and conductor tension. Terminal poles set up at the beginning and end of power distribution lines are a type of tension pole. They can bear vertical loads and wind pressure on one side of the conductor, as well as the tension of the conductor on one side. Branch poles are generally used when branching lines are needed in overhead lines. Crossing poles are used for crossing railway, highways, rivers, power lines, and other crossings, ensuring a safe distance between the conductors and the objects being crossed. These poles usually need to be raised higher to reinforce line safety and ensure sufficient tower strength, and additional staying wire are required. Now, let's learn about foundations. The function of foundation is to support and stabilize poles, preventing them from sinking, tilting, or uplifting. The types of foundation commonly used in power distribution lines are mainly concrete foundations, with a few places using steel-type poles and iron towers. Therefore, the types of foundation for power distribution lines mainly include base plates, clamps, and pour plates. Conductors play a role in conducting electricity and transmitting electrical energy. They can be divided into bare conductors and insulated conductors. Bare conductors are classified into single-strand wires, single metal multi-strand twisted wires, and composite metal multi-strand twisted wire. Composite metal multi-strand twisted wires include steel core aluminum wires, expandable steel core aluminum wires, hollow conductors, steel aluminum composite stranded wire, aluminum clad steel wires, etc. The models of overhead conductors are usually represented by Chinese phonetic letters and numbers, with letters before numbers. Insulated conductors are needed due to the increase in urban construction and population density, as well as the development of urban greening, which occupied most of the line corridors, especially in large cities. In low-voltage overhead bare conductor lines, many problems have been exposed, hence the need for insulated conductors. Next, let's learn about insulators. The function of insulators is to support or suspend conductors and form electrical insulation between conductors and poles. They not only need to withstand changes in weather and chemical corrosion, but also require good insulation performance and sufficient mechanical strength. Insulators can be divided into porcelain insulators, glass insulators, and composite insulator based on their materials. Porcelain insulators have a long history and stable insulation performance, but defects are not easy to detect. Glass insulators have the advantage of self-exploding after degradation, still maintaining high mechanical strength and stable performance. The umbrella disc of composite insulators is made of a silicone rubber-based polymer with good hydrophobicity and strong pollution resistance. The core rod is made of epoxy glass fiber, which has high tensile strength, vibration reduction, good creep resistance, and fatigue fracture resistance. Overhead power distribution lines commonly use insulators include suspension insulators. Suspension insulators are generally used in low-voltage lines. A single suspension insulator suspending a conductor for 10 kV lines. A string of two insulators is used to suspend the conductor, while pin insulators are made more suitable for low-voltage lines with less conductor's tension. Conductors are usually tied with metal wires at the top of insulators. Pin insulators can be divided into high-voltage pin insulators and low-voltage pin insulators based on their voltage level. Current insulators are basically similar to pin insulators. The characteristic structure of this insulator is that the insulating porcelain is poured into the bottom iron shoe to form an iron-clad porcelain external pulling structure, thereby reducing the occurrence of porcelain cracking faults. However, it can only be used on overhead, straight-line pole conductor angles with small angles, and cannot withstand lateral wind forces exceeding its allowable bending strength. Butterfly insulators are commonly used in low-voltage lines. Next, let's learn about fittings. Fittings are used to support, fix, connect, and protect various components, also known as iron fittings. Fittings can be divided into several types based on their performance and uses. Support fittings are used to support conductors and various metal components of equipment, including various specifications of iron cross-arms and various brackets, such as clamps, tension rods, screws, and cross-arms. Fixed fittings include suspension line clamps, mainly used in lines with voltage levels of 35 kV and above, as fittings for fixing conductors to straight poles. Tension line clamps are mainly used to fix conductors to the insulator streets of tension poles or to fix ground wires to the top of towers. Connecting fittings refer to assembling insulators into street and connecting them to all metal components on the cross arms of towers, including ball end hangers, extension rings, U-shaped hangers, parallel hanging plates, and ball hanging plates. Protective fittings are used to reduce the vibration damage of conductors and ground wires and protect them. They are mainly used in overhead power lines with voltages of 110 kV and above. Protective fittings are generally not used in distribution lines. Tension line fittings include wedge line clamps, mainly used at the upper end of line tension rods. Their connection method is to connect with tension line clamps through extension rings. In lines with ground wires and voltage levels of 35 kV and above, wedge line clamps can also be used to fix ground wires to the tops of towers and bear the tension of ground wires UT-type line clamps are mainly used at the lower end of tension rods. Next, let's learn about tension rods. The function of tension rods is to stabilize pulls and reinforce unbalanced forces. The structure of tension rods consists of tension rod clamps, extension rings, wedge line clamps, upper rod heads, steel strands, UT line clamp, lower rod heads, tension rod bars, U-shaped screws, and connecting levers. Types of tension rods can be classified as follows. Ordinary tension rods are mainly used to balance unidirectional forces and increase the stability of pulls with a normal ground angle of 45 degrees. Zigzag tension rods are mainly used in windy areas and are installed vertically on the line to increase the lateral wind resistance of pulls. So they are also called wind-resistant tension rods. Horizontal tension rods are used to cross roads or other obstacles. They need to be installed outside the direction of the obstacle to pull the line. A horizontal tension rod anchored stake is set upright at the base of the line to cross the obstacle, while another tension rod is driven downward to bear the tension. The horizontal tension rod crossing the road must have a vertical distance from the center of the road surface of not less than 6 meters. Arch tension rods, also known as self-tension tension rods, are used to prevent pull bending and balance the uneven tension of conductors. When it is not possible to use ordinary tension rods due to terrain restrictions, Y-shaped tension rod, also known as V-shaped tension rods. When the pull is high, the cross arm is many, and there are more conductor wires, are installed at 2 points above and below the resultant force point. The lower parts are combined into a V-shaped tension rod. X-shaped tension rods are commonly used on gate-type double poles, where the cross-arm is mainly integrated with the tower to support insulator, conductors, and current-mounted distribution equipment. Students, in this class, we mainly introduce the names, functions, and types of components of overhead power distribution lines. It is important to be familiar with them. You also need to accumulate more knowledge in your daily life. That's all for this class. Thank you, everyone.